Hello guys, my name is Nediton Chirudashot, and today I will talk about effective computing, giving machine emotional intelligence. So what is effective computing? Effective computing, also called emotional AI, is a field of artificial intelligence. It focuses on systems that can recognize human emotions, interpret emotional signals, and can respond appropriately. And the goal is to make human-computer interaction more natural. So in the right here, this is the AI trying to recognize what emotion does the Mona Lisa is having. And as you can see, the most common one is the neutral emotions and happiness emotion. Okay, so let's see the overview from her.
Hi, I'm Rosalind Picard. I'm a professor at MIT, and I work in the Media Lab where I direct our research in affective computing. Affective computing started here in the Media Lab. I originally defined it as computing that relates to, arises from, or deliberately influences emotion. In the beginning, it was seen as a kind of a crazy idea, but today it's in use by more than a quarter of the Fortune Global 500 companies. Affective computing today is inside robots, voice assistants, automobiles, smartphones, and all kinds of technology that we interact with daily. The focuses of our affective computing research range across a broad set of areas. The technology enables us to do things like see if a user of technology is interested, bored, confused, frustrated, and not just on their face, but we can, if they choose, and all of our work involves opting in and fully informed consent, we can also listen to tone of voice. We can look at sentiment analysis of what is typed online and help you see, for example, if your media diet is full of negativity or full of more positive, joyful, happy, and engaging stimuli. The technology lets us do things like improve the safety of a driver's experience, recognizing things like where their attention is going and when they might need additional support. Over the years, there have been a lot of surprises in our work as well. For example, with the collaboration across the Media Lab, we pioneered some of the first wearable technology. And my group's focus was on the physiology that relates to emotion, things like stress that influences how all of our organs function, and engagement that also influences our mental health and our social interaction. With understanding that physiology and wearables, we've had a lot of surprises, such as seeing physical health changes, like neurological changes that relate to a seizure, and behavioral changes that relate to mental health. As a child, I was not interested in emotion. Even as a young researcher, I thought it was something we should stay away from. But reflecting back, I realized that I was raised in a family with great emotional intelligence. My parents, who adopted my brother and me, for example, helped us have the courage to see when expectations were set very low and to defy those. In high school, as a young girl, I was told that if I ever wanted to work, I should learn to type. Take the typing class, because then if I wanted a job, I could become a secretary. Well, I did take the typing class. I became a very fast typer, and I later was able to use that to create computer programs, author the book Affective Computing, and today my group and I have published hundreds of peer-reviewed scientific publications. I learned then, and continue to learn now in the Media Lab, that you don't have to be restricted by the training that you have. I'm trained in electrical engineering and computer science, but today I partner with doctors, with lawyers, with philosophers, with people who have really hard problems to solve and don't know how to solve them. But those problems intersect with human emotion and technology. And when we bring together all of our kinds of expertise, we can defy the expectations of those around us and come up with creative new solutions that really help address these important human problems.
Okay, so for the origin of the field, so the person who is talking in the video is Rosalind Picard. She is from Massachusetts Institute of Technology, and he is the founder of this field called effective computing in 1997. And in the book, the paper, she focused on giving machine the ability to process emotion. And the core idea of her paper is that computers should understand emotion, not just logic. So why effective computing matters? So human communication includes facial expression, tone of voice, and emotional context. So traditional computers usually ignore those emotions, and this creates interaction that feels unnatural or limited. And the effective computing is trying to solve this problem by improving the user experience by adding emotional awareness. The key concept of the effective computing, it aims to recognize emotional signal, interpret emotional meaning, and respond in an adaptive way. So system can adjust behavior based on how user feels. This leads to more personalized and effective interaction. How the effective computing works. So basically, first it captures the emotional data, and then it analyzes the patterns. It detects emotional state, and it generates appropriate response. So the type of input is quite many. There are like facial expression, voice tone, text, and physiological signal. In the right picture, you can see that the human has many kind of organs that can take the input such as face, hand, body, and voice. And we can take inputs from those and feed it into the AI, and it will gonna generate the effective status. So combining multiple signals improve accuracy and reliability. So the emotional recognition system detect emotions from facing facial expressions such as smile, frowns, the speech patterns such as tone, pitch, and text such as sentimental analysis. And the machine learning models classify those emotional states. Then the AI learn the pattern from data to recognize emotion. The more data available, the better the system performs. So in the right, we use like the face tracking to feed the data into the algorithm. The emotional representation, there are two main approaches. So the first one is the discrete model. Emotions are categorized into many kinds such as happiness, sadness, and anger. And the second one is continuous model. So the emotional exists on a spectrum and can be ranged from positive to negative. These models allow emotion to be processed mathematically. And in the right is a many type of emotions. The role of artificial intelligence. So AI analyze emotional data using machine learning, deep learning, and the system improvises over time with more data. This enables more accurate and adaptive emotion detection. For the example, such as detecting frustration, and adjusting system behavior. So the picture on the right is a type of AI classification of the emotion, such as like machine learning and deep learning, and like facial expression recognition. So we use like many kinds of tools to get the data to analyze. The application of effective computing, such as healthcare, education, marketing, customer service, automotive system. These applications focus on improving user experience and decision making. And emotional awareness helps system respond more effectively to users. In the right is a tool, the application for the healthcare. It is called the BioEssence wearable, and it detects stress or pain and release a scent to help the wearer adjust to the negative emotions. Also, the example of marketing. So the system analyzes emotional reactions to content, and it detects interest, confusion, and engagement. And it helps companies understand how users react in real time. And it improves design of advertisement and digital context. So for the second example is healthcare. It analyzes or behavior patterns, and it detects stress, anxiety, and mood change. And it supports early detection of mental health conditions, and it can provide continuous monitoring outside clinical settings. For the third example, we have automotive system. So this monitor driver's emotion, it detects fatigue and stress, and it adjusts system behavior for safety. It can warn driver or assist in controlling the vehicle, and it improves safety and reduce risk of accident. So the challenge of effective learning, the emotions are complex and subjective, and it's quite difficult to measure accurately. And there are cultural difference and affect interpretations, and it requires large and reliable dataset. So small errors in detection can lead to incorrect system response. So the ethical issue of the affective learning, the emotional data is highly sensitive. There are privacy concerns and risk of misuse in like surveillance, for example, and there are bias in AI model. So system must be designed with transparency and user consent, and ethical considerations are critical for real deployment. In the right hand is the triangle for technical challenge, ethical implication, and social implication. And these are very important things to consider. The future of effective computing. In the future, there will be more natural human-computer interaction, then emotional aware AI assistant, and integration into everyday technology. System will become more context-aware and personalized, and emotion AI will play a key role in the next generation interface. The key takeaway for effective computing is an emotion-aware AI. It enhances interaction between humans and machines. It uses AI to detect and respond to emotional signal, and it has wide application and important challenges. So balancing performance and ethics is essential. Okay, thank you for listening. this. So